morning, everyone. This chapter, dual nature of matter and radiation, or you can say that the radiation and matter, deals with the duality in nature of matter, namely particle nature and wave nature. Various experiments by various scientists were done to prove it. For example, light behaves both as a wave and as a particle. If you are observing phenomena like interference, diffraction, or refraction, you will find that light behave as a wave. But if you see that the phenomena like photoelectric effect, Compton effect, you will find out that light behave uh, as a particle. You, for an example, if you see that in your class 10th, uh, we study about the solar energy. Solar energy as a source of electricity using solar panels. Solar panels has a solar cell. When photons hit the solar cell, the electron get excited, and due to their movement, electric current is produced. So here we got to know that the light constitutes of photons, or in other words, light contains particles which are a packet of energy. Now, as we all know that in metals, the electron in outer shell of the atom are loosely bound. Such loosely bound electrons are called free electrons. The free electrons cannot leave the surface of the metal under ordinary temperature and under moderate electric field. The moment an electron comes out of a metal surface with its negative charge, the metal surface acquires an equal positive charge and pull it back. Now there is a potential barrier at the metal surface which the free electron have to overcome in order to just escape from the metal surface. Or other word, you can say that it requires a minimum amount of energy so that it can escape from the surface of the metal. That energy is called work function. In next class, we are going to study about the work function. Now again, we are going to discuss about the work function. Again, we say that the minimum amount of energy required by electron just eject from the surface of the metal is called work function. Work function can be denoted by W naught, and the unit of this work function is taken as electron volt. Now, definition of 1 electron volt can be explained as the 1 electron volt is the kinetic energy gained by an electron when it is associated through a potential difference of 1 volt. Or you can say that the energy gained by the electron is equals to the work done by the electric field. It is equals to QV. Now you will take the value of Q as the charge on 1 electron and V taken as 1 volt. In that case, 1 electron volt is equals to 1.6 into 10 to the power minus 19 into 1 volt. That will give you 1.6 into 10 to the power minus 19 joule. Now if you see this is the definition of work function. Now here it is denoted by W naught. That is now this is the definition of work function. Now here energy gained by electron is equals to work done by the electric field. You always remember this point. For numerical, you will have to remember this point. Energy gained by electron is equals to work done by the electric field. Now 1 electron volt is equals to, now here 1.6 into 10 to the power minus 19 into 1 volt, that will give you 1.6 into 10 to the power minus 19 joule. There are different types of method for electron emission. One of them is thermionic emission. In thermionic emission, the metal is heated to a sufficient temperature to enable the free electron to leave the metal surface. The number of electrons emitted from the surface, metal surface basically, depends upon the temperature. If the temperature is higher, then the emission of electron is also greater. The ejected electrons in this case are called thermal electrons या thermionic electrons. Now we discuss field emission. In this case, when a metal surface is subjected to a very high electric field, electrons are emitted from its surface. This phenomenon is known as field or cold cathode emission. This method of electron basically emission is dangerous and less efficient. Now we discuss about the photoelectric emission. Now it is the process in which electrons are emitted from a metal surface when electromagnetic radiation of sufficiently high frequency are incident on it. The emitted electrons are called photoelectrons, but their rate of emission is very low in this case of emission. Now in such type of secondary emission, when a fast moving electron strike a metal surface, they transfer some of their energy to the free electrons of the metal. As a result of this, the energy of free electron becomes more than the work function of the metal. Therefore, they get ejected from the surface of the metal. The emission of such kind of electron is called secondary emission, and the emitted electron is known as secondary electron. Now we discuss about the photoelectric effect. We can understand this photoelectric effect when a radiation of sufficiently high frequency, that is greater than threshold frequency, incident on a metal surface, the electron is ejected from the metal surface. Such phenomena is called photoelectric effect. The electron ejected from the metal surface is known as photoelectron, and the current due to these photoelectrons is known as photoelectric current or photocurrent. If you see that here, now this now here this the electron emitted by this effect are called photoelectron, and the current constituted by this photoelectron is known as photoelectric current or photocurrent. Now similarly, if you see the definition of this photoelectric effect, the phenomena of emission of electron from the metal surface when the radiation of suitable high frequency is incident on it. This high frequency must be greater than the threshold frequency. Now we talk about the Hertz observation. The photoelectric effect was first discovered by German physicist Heinrich Rudolf Hertz. He performed a simple experiment in which he has taken two metal electrodes and applied some voltage across these two electrodes. He found that when a ultraviolet light incident on the metals plate of these electrodes, the voltage across these electrodes is going to be changed, due to which a sparking takes place between these two electrodes. Now the reason behind that is it is happened due to the emission of electrons in the atmosphere. Now we discuss about the Hallberg and Leonard observation. Now Hallberg and Leonard first observed that when the frequency of incident light was less than the certain minimum value of the frequency called threshold frequency, there is no photoelectron are emitted from the surface of the metal. Now, the different substance emit photoelectron only when they exposed to the radiation of different frequency. The second point, he observed that, and like algae metal like lithium, sodium, potassium are highly photosensitive. They emit electron even in the visible light. And metal like zinc, magnesium, aluminum, etc. respond only to ultraviolet light. X-ray can eject electron even from the heavy metals.